So today we're going to talk about Chapter 6, and it's on rational exponents and radical functions. And Section 6.1 is on evaluating nth roots and using rational exponents. And that's what our goal is today, is to evaluate the nth roots and study rational exponents. Now when we talk about the nth root of a for an integer n greater than 1, it says if b to the n is equal to a, then b is an nth root written as the nth root of a. And so when we talk also about the index of a radical, that's the integer n greater than 1 in the expression. Now if we look back, we've done a lot of work with square roots. Well, in a square root, there's not a number there, but it's really a 2, because what it's telling us is what number multiplied twice will give us 4, and that is 2. So we know that the square root of 2 is 4, because 2 times 2 is 4. Now, today, in this section, we're going to be looking at radicals that have index numbers other than 2. Some of them may be 2, but some of them might be 3 or 4. So we're looking at those types of numbers. But the index of the number is the number inside the radical. Great. The base here. That is our index number. So we talk about the real nth root of a. It says let n be an integer, n is greater than 1, and let a be a real number. Now we're going to have two scenarios here. First, n can be an even integer. So we could have an index number that's even, or we could have an index number that is odd. Now the rules for the even numbers are just like the ones that we have for the square root. So these are not any different. If a is less than 0, so if the number inside our radical is negative, there are going to be no real roots because it's imaginary. No number multiplied an even number of times will get you a negative number. So in that case, there's no real roots. If it's 0, we're going to have one real root, and it's going to be 0. And then if it's positive, we're going to have two real roots, the plus and the minus of that root. So that's the same as our square roots. Now the difference comes in when n is an odd integer. If a is less than 0, we're going to have one real nth root. When a is 0, we're going to have one real nth root. And when a is greater than 0, we're going to have one real nth root. So those are all going to be 1. Because when we take the square root of a number like, or let's say the third root. So if I take the third root of a number like -8. Well, what times itself 3 times gives you -8? Well, we only have one possibility, and that has to be -2. -2 times -2 times -2 is -8. That's the only one. 2 is not going to work. 2 is going to give us +8. So in each of those cases, if our index number is odd, we're only going to have one solution. All right, so if we look at example 1 is on finding the nth root. We're going to find the indicated real nth root of a. And we have the 5th root of -32 is really what they're asking. So what number 5 times will multiply to give us -32? And so our answer here is -2. And notice there's only one solution here because this is an odd number. And so -2 times -2 times -2 times -2 times -2 is going to give us -32. Now in the next one, our index number here is even. Well, that tells us, and this is positive, so that tells us automatically we're going to have two solutions. So in this case, it's going to be plus or minus 1. So jumping down now to the rational exponents, this is just going to be a different way to write these. Now, sometimes using radicals is going to work much better. Sometimes using rational exponents is going to work better. But here's how we how we transform them from one to another. It says let a to the 1 over n be an nth root of a, and let m be a positive integer. Well, if we have a to the m over n, I can break that apart as a to the 1 over n raised to the m power, which means this is the nth root of a to the m power. Now, if we look at this, the denominator of our fraction is always going to be the index number. So if we have, for example, 3 to the 4 sevenths, I could write this as the 7th root of 3 to the 4th power. And likewise, if we go down to the next one, it says a to the negative m over n. Now we also remember you cannot have a negative exponent, so that's why we take this to the bottom. That's a terrible arrow. We move this to the bottom, we get 1 over a to the m, and then it's exactly the same. So if we have, let's say, 3 to the negative 3/5, well, that's going to be 1 over 3 to the 3/5, which is 1 over the 5th root. Remember, our denominator is our index number, 3 to the 3rd power. So if we jump down to example 2, that's all they're really asking us to do. They're asking us to evaluate these expressions with rational exponents. So if we do that, in this case, we're going to write these as radicals. I'm going to write the 3rd root of 125 to the 2nd power. Now the reason that we do these is we can write it like this, is we can break this apart. And you'll get better at understanding which ones are 3rd roots and 4th roots and 5th roots. But I look at this and I can see that here the 3rd root of 125 is 5. So this is going to equal 5 squared. So I reduced what's inside that radical first. And so now 5 squared is 25, so that's our answer. And we're going to do the same thing over here. I'm going to have 1 over 8 to the 4/3. And I'm going to write this now in radical form rather than with rational exponents. So it's going to be 1 over the 3rd root of 8 to the 4th power. Well, the 3rd root of 8 is 2. So we're going to have 1 over 2 to the 4th. And 2 to the 4th power is 16. So our answer in this case is going to be 1 over 16. The next thing we're going to look at is approximating roots with a calculator. So we're going to evaluate the expression using a calculator. And they say round your results to 2 decimals when appropriate. Well, when we look at this, we're going to do this. You can do this in a variety of ways. You can use it, plug them in using rational exponents, just like it is, or you can plug it in using radicals. And I'll show you how to do both. So make sure you have your graphing calculator and pull those up. And so we'll show you how to do it using the rational exponents first. And this is probably the easiest, but the first one was 22 to the 1/4. So I'm going to go 22, and then I'm going to hit my caret button. And then it's going to go to, I'm going to put parentheses in, 1 divided by 4. And then there's my answer. So it'll be approximately 2.17. The next one, same thing. We'd have 35 raised to the 5/6. So it's going to be 5 divided by 6. And that one's going to be approximately 19.35. And then the next one, if we look at that, coming back to here, that one is in radical form. So we're going to look at how do we do that in radical form. So if you look at, there's the math button right here. And some of you will have to do this a little bit different, but number 5 says we have a x root. So I'm going to hit that button. And in my calculator, it gives me the 2 spots to plug them in. Some of you may have to hit the 5 before you hit that button, or whatever the index number is. So I'm going to put my 5 here, and then I'm going to go to the inside, and it's going to be 11, not 111. And then I have to go outside of this, and I'm going to raise that to the 4th power. And that gives us 6.81. Now, what you also could do is hit enter after you hit the 5th root of 11, and then raise it to the 4th power if it doesn't give you that answer. So those would be your answers for those 3. We'd have approximately 2.17, 19.35, and 6.81. So what I would like you to do is go ahead and do the guided practice questions, and there's 12 of them there, so you can zip through most of those. But go ahead and do those quickly. Pause the video until you are done with those, and then you can hit play when you're ready to move on. And here are the answers to all of those guided practice questions. 1 through 4, and we're just using the index numbers to find the roots. Remember, if the index is odd, we're only going to have 1. If it's even, then it's just like the square root ones that we talked about before. And here's how we evaluate our rational expressions and our radical expressions with and without a calculator. All right, now we're going to get into solving equations using nth roots. And this is really what these sections are all about. We're going to look at how do we solve these using the rules of exponents that we just learned. Now again, everything that you're going to do is exactly the same as the solving the square roots that we just got done doing until you get to the very last step. So in example A, we're going to do the same thing. We're going to take and we're going to divide by 6 because we want to get the x cubed by itself. So we're going to have 384 divided by 6. Well, that's going to give us 64. So we have x cubed equals 64. And now we take the 3rd root of both sides. Right? When we had to square, we took the square root of both sides. When we have a third, we take the 3rd root of both sides. So I'm going to take the 3rd root of both sides. Now, remember, when we took the square root, we always had a plus or minus. In this case, we're not going to have a plus or minus because this index number is odd. There's only going to be one solution to this problem, and it's going to be, well, what is the 3rd root of 64? It is 4. And so 4 is the answer to this problem. B, we're going to do the same thing. Now, we have x minus 8 in the 5th, or to the 5th power. So what we're going to do is we're going to take the 5th root of both sides. So it's going to be x minus 8 equals, and again, it's not plus or minus because we don't have an even index. 5 is an odd number. So we have the 5th root of 100. So we're going to take the 5th root of 100, which is approximately 2.51. Now notice it's not an equal anymore because it doesn't equal 2.51. It's approximately 2.51. So now we're going to add 8 to both sides. And so our x is going to be approximately 10.51. Jumping down to example 5. Now we're going to use nth roots in problem solving. So it says an exercise ball is made from 7,854 square centimeters of material. Find the diameter of the ball. Use the formula S equals 4 pi r squared for the surface area. So we know that the area of our surface is 7,000. Well, let's write the formula first up here, and we'll just plug our numbers in. S equals 4 pi r squared. So it's 7,854 units, square centimeters here, 4 pi times r squared. And our goal is to solve for r squared. So when we are doing this, we're going to just go ahead and get the r squared by itself. So we're going to divide by 4. And if you wanted to, you could divide by 4 pi right away. But I'm just going to divide by 4. And so we're going to get 1,963.5 equals pi r squared. Now we divide by pi, and that's going to give me about 625 r squared. And so now you take the square root of both sides. Now this is an even index, so we have to have a plus or minus here. So r is going to be approximately plus or minus 25. Now, in a real life situation, the negative one doesn't make any sense. Our radius cannot be negative 25 centimeters. So now, once we have solved this, we have to go back and make sure that we answer the question they asked. They asked for the diameter of the ball. Well, we solve for the radius. So if the radius is 25 centimeters, the diameter is approximately going to be 50 centimeters. Okay, and so there would be the answer to the question. So we're going to take a little bit of time now to go ahead and do the guided practice. So there's 6 of them here. Go ahead and solve these. Make sure that you can do these. If you can do this part, this is kind of the main part of this section. So go ahead and take some time to do those. Go ahead and pause the video, and then you can hit play when you're ready to move on. All right, and here are the answers to the guided practice questions. Now, if you notice in 13, 14, 16, and 17, there are only one solution. And that is because each of these is an odd index. So again, if it's an odd index, there's only going to be one solution. But if we look at questions 15 and 18, we have 2 solutions in both of those. And that is because the exponent, or the index when we turn it into radicals, is even. So if it's a second or a fourth or a sixth or whatever it happens to be, if that's an even index, we're going to have 2 solutions. So as a recap, section 6.1, we are looking at evaluating nth roots using rational exponents. So the majority of this section we're pulling together is we're doing the same thing that we did with square roots, but now we're using roots or indexes that are bigger than 2. So we're using third roots and fourth roots and fifth roots. And the major thing that we need to come out of is just what we just got done talking about. If the index is odd, you're only going to have one answer. If the index is even, you're going to have to look at whether that number inside is positive or negative to give us those solutions, or 0. So here is your homework sets. So that is the assignment for section 6.1.